Language, a repository of letters, which can be strung together to create meaningful messages. We are taught that our ancestors invented language, which has transformed and melded together over time. But what if our distant relatives didn't intentionally make language, but instead were simply the first to uncontrollably express a pre-written script ingrained deep within the human soul? What if messages were supernaturally programmed into language before man even drew his first alphabetical symbol? And what if these secret messages can be used like clues to investigate reality's timeline of events? Join David Mivshek, author of Reality's Storyline Decoded, as he tells the past, unlocks the future, reveals our Creator's mind, and explores other esoteric and philosophical topics through the powerful decryption technique he calls fate stacks. January 16th, 2003. 7 astronauts board NASA's Space Shuttle Columbia and take off on what is called the STS-107 mission. Even though this group of astronauts would successfully reach outer space and travel 6.6 million miles over a span of 15 days, landing back onto the surface of Earth safely would prove to be a more harrowing challenge. Could the astronauts' fateful ending have been predicted? And could it have been stopped? Using the fate stack method, if it was applied before the Space Shuttle Columbia STS-107 mission launched, could have lent a helping hand in foreseeing and avoiding the Columbia crew's fateful demise. 7 astronauts: Laurel Clark, Jan Ramon, David Brown, Kalpana Chawla, William McCool, Rick Husband, and Michael Anderson, all born at different times, and all born in different places. 7 separate life storylines, and 7 different alphabetically based identities that would end up converging and melding together on their lofty journey to reach the stars. Construct the Columbia STS-107 astronaut's fate stack by adhering to the predefined fate stack construction rules. Vertically stack the last names of all 7 astronauts who flew in the Columbia STS-107 mission by listing the shortest of the astronauts' last names on top to the longest last name on bottom. Last names are used because they uniquely identify people when the people belong in a group of people carrying out a specific task. If we continuously compare 2 categories of people, the first category identified by only the people's first names, and the second category identified by just the people's last names, we would see over numerous examples that groups of people who've come together to carry out a specific task are more uniquely identified if the people are tagged with just their last names. This is because, in most cases, less people in a group have the same last names than they do first names. Fate stacks aren't constructed using people's first and last names because then it could easily be argued that with so many letters available, it's no surprise that some type of answer could be made. So having less letters available shrinks the possibility that a fate stack answer can be made, and using only last names helps to uniquely identify the group of people being investigated. If more than one last name contains the same amount of letters, and therefore they share the same length, like the last names Clark, Ramon, and Brown, or Shala and McCool, as seen in this fate stack, the vertical order of the last names having the same length is decided by the decoder while they're solving the fate stack by selecting the vertical order which allows the most sensible answer to be made. Until a mathematical algorithm becomes available which can be used to vertically order names of the same length, manual vertical adjustment by a fate stack decoder is relied on. Now make sure all of the name rows are left aligned so that the first letter of each last name is in the same leftmost letter column. Next, put each subsequent letter of each last name into the same column. So the second letter of each last name is in the second letter column. The third letter of each last name is in the third letter column. So forth and so on until all of the letters of all of the last names making up the fate stack are adjusted into an evenly spaced latticed matrix of letters. One thing that we need to keep in mind as we see the fate stack method work is that the people whose last names are used in the fate stack didn't choose what their last names were, or the letters that are used to spell them. And so when the letters of their last names are connected to reveal an answer that spotlights an important event they experienced together, we must question how can the letters of their last names also be used to spell words which form an answer that describes events experienced by the same people whose last names were used to construct the fate stack. A method that works not only once or twice, but time and time again. To solve the Columbia STS-107 astronaut's fate stack, connect the letters of the astronauts' last names horizontally and/or vertically to spell new words. Every letter in the fate stack matrix must be used, and used only one time. The new words are the answer words. They should enhance the fate stack answer's meaning. They should be words like nouns, pronouns, verbs, adverbs, or adjectives. To make a fate stack answer, remove the newly formed words out of the matrix in a top left to bottom right hand sequence, in the same direction you'd read an English paragraph. Remove and list each answer word only once to minimize word redundancy. List the answer words linearly in the order they were removed, and add punctuation to give grammatical structure to the answer and to clarify the answer's meaning. A fate stack answer can only be a message reporting on the people whose last names were used to construct the fate stack matrix, and/or noteworthy events relating to them. Applying the fate stack method to the last names of the astronauts aboard NASA's Columbia STS-107 Space Shuttle mission yields the answer calm or known crab char blow, land, chums arose, and no. But seeing these words pieced together into sentences without knowing what definitions to apply to them might make the answer look like a confused, jumbled mess of nonsense. So let's define the answer words that we need to help make the answer's meaning clearer. Calm means absence of worry or fear. A crab is a defect making something troublesome to use. Char means burn something to charcoal. Blow means explode, shatter, or utterly destroy something. Land means to alight or descend from a vehicle. Chums are friends, or roommates, and a rose means went from a lower to a higher position. By assigning definitions to the answer words, we can clear up the meaning of the answer's message. The answer's first sentence says, "There is absence of worry or fear," or a calm. This calm relates to a known defect, or a known crab. This known defect causes something to burn severely, or char, and explode, or blow. The first part of the answer's second sentence asks a question. Does someone descend from a vehicle or land? Then there's an answer to that question. Friends or chums went upwards or arose, but no, never came back down. And when we compare the answer's meaning to the harrowing events surrounding STS-107's re-entry phase, we can readily see how well the answer describes the events surrounding STS-107's re-entry phase. February 1st, 2003. During Space Shuttle Columbia's re-entry phase, hot gases entered a hole in the Space Shuttle's left wing, caused by a suitcase-sized piece of foam that broke off of the spaceship's external tank 82 seconds after liftoff. The damage was caught on video, but was not deemed a threat, since foam shedding had been witnessed in at least 4 other space shuttle missions, which all ended successfully and safely. This time, however, the results of foam shedding would not end up so well. Eventually, the hot gases entered into the space shuttle, and through various internal atmospheric chemical reactions, caused the Space Shuttle Columbia and its crew to disintegrate into a luminescent streak of light in the morning skies over Texas. Foam shedding, the known crab, the known defect that no one was worried about, to the point that even astronauts brushed it off as a necessary evil to achieve their dreams of space travel. However, for the crew of Space Shuttle Columbia STS-107, foam shedding would be the cause of the charring of their human flesh-based spacesuits and the blowing apart of not only the vehicle that took them into space, but also themselves. So next time you flip a coin into the air, or jump on a trampoline, remember the Space Shuttle Columbia STS-107 and its crew, because sometimes what goes up doesn't necessarily come back down, or in the way you had expected, or at least hoped for.